Let's look at some word problems that involve quadratic equations. To solve them,
perhaps I could be of some assistance.
We're still going to use the same basic steps that we used for all word problems.
Pay attention, son.
Do you remember what they are? Do you remember what the most commonly skipped step is? Step number 1. Name what they want to know. Name what x is. If you get baffled and you don't even know what you're looking for, of course you're going to have a problem. Recall that x can only be one thing. It can't be Susie and Jim's age. And when in question, usually let x be the smaller of the several things that are involved in the problem. Then once you've named what x is, define everything else in the problem in terms of x. And start with deciding what you want to interpret. In other words, start in English. And cross out as you go. Because most of the time, if you cross out what x is and what everything else in the problem in terms of x is, all of those are going to add up to what we call the Math to English Dictionary. And once they're gone, what's left is the equation. Interpret what's left from your Math to English Dictionary. Then we'll solve the equation and answer the question. Now with quadratics,
Excuse me, Professor Brainiac.
there's going to be a couple additional factors to solving those word problems. You know what's going to crop up a lot in quadratic word problems is area. Because the area of a shape is measured by the number of squares that can fit into it. And of course quadratics involve squares. X squared. That's what makes it a quadratic. The area of a rectangle is length times width. Okay, that's a formula we can use. And the area of a triangle is 1/2 base times height. So that may be involved often in a quadratic word problem.
Whoa!
And don't forget, with quadratics, you're generally going to get 2 answers. They may be the same number, but they're going to be 2 answers. So there's probably going to be something that gets knocked out, because we really only want one answer, one final answer. And length, if length is involved, it can never be negative. So you'll just cross that out if you get a negative answer for length anyway. Okay?
And now, ladies and gentlemen, let's get ready to rumble!
Let's try one. This one's a typical quadratic area problem. The length of Joe's kitchen floor is 4 feet more than the width. The area is 117 square feet. We want to know the length and the width. So let's follow our steps. Number 1, most importantly, name what x is. Name what you want to know. Now in this problem, we want to know 2 things. We want to know the length and the width. So let's let it equal the smaller. I'll have x be the width. Well, that means in step 2, when I define everything else in the problem, I'm going to begin with, since I've already done the width, the length. And the length will be, as it says, 4 feet more than the width. And the width is x, so the length will be x plus 4. Now, let's cross out what we've done, the length and the width, and that the length is 4 feet more than the width. Now there's another word in here, the word area. I should define that as part of problem 2 as well. The area of this thing, well, we're going to say it's a rectangle. And the area of a rectangle is length times width. So the area is going to be, in this case, length times width, or width times length, or x times x plus 4. That's the width times the length. Now, the nice thing about crossing things out is whatever's left is going to give me my equation. I have the word area in step 2. So the equation will be the area is
Excellent.
117. There's your equation. That's why I cross things out. Okay, let's solve this equation. Distributing the x, I get x squared plus 4x equals 117. Let me subtract 117 from both sides, and I'll get x squared plus 4x minus 117 equals 0. Now we're going to be nice to you. since this is a word problem, let's solve by factoring. I promise you that it can factor. I factor to x plus 13 and x minus 9, meaning that the answers are either negative 13 or 9. That's what makes each of those factors be 0. Now, we're talking about x, and x is the width. If I'm going to answer the question here, and x is the width, I have two possibilities, negative 13 and 9.
Excuse me?
It can't be negative 13, so I have to throw that out. Okay? So the answer for the width
Is that your final answer?
is 9. But they also wanted to know the length. Good thing I wrote that down in step 2. The length is x plus 4. X is 9. So the length is 9 plus 4, or 13. So the answer is, the width is 9 and the length is 13.
Think you'll come again.
Let's try another. This one's going to be a little bit more challenging as far as interpretation. The sum of the squares of two consecutive negative integers, that's a lot of words, is 221. And they want to know the two numbers. Well, keep your cool. We've got to define x. We have two numbers here. Let's let x be the smaller integer. Okay, so we'll work our way. That's step 1, done already. What else is involved in this problem? Well, in English, I've got the next consecutive integer, and that is, if x is the smaller integer, the next number is x plus 1. Okay, now I need some squares here also. Let's see, I need the square of the smaller integer. If the smaller integer is x, the square of that is x squared. I also need the square of the next consecutive integer. Now the next consecutive integer is x plus 1. So the square of that,
Excuse me, Professor Brainiac.
yes, the square of that is x plus 1 squared. Let's see if we can write an equation. The sum of the squares, look at the two things you wrote down that are the squares. The sum of the squares of the two consecutive integers is 221. So the square of the smaller one plus the square of the larger one is 221. There's your equation. Now we've got to solve this bad boy. Let's see. I'm going to go ahead and multiply x plus 1 times x plus 1. In other words, x plus 1 squared. And I'll get x squared plus, doing all the multiplication, this equals x squared plus 2x plus 1. Now, let's put those two like terms together. And I'm going to bring the 221 over. Okay, now I could factor at this point, but remember the first step to factoring is to take out the common factor if there is one, and there is one in this case. So I took a 2 out. Then, let me factor a little further, and I'll get 2 times quantity x plus 11 and x minus 10, which means I have two possible answers, either negative 11 or 10 for x. Now in this problem they originally said that these were negative numbers.
No way.
So we have to, believe it or not, so we have to throw out the positive number. So our smaller integer is negative 11.
Is that your final answer?
That's the smaller number. Now what's the next larger number? Negative 11 plus 1. Yep, negative 11 plus 1 is negative 10, isn't it? And if you think about it, the square of negative 11 times negative 11, 121, plus the square of negative 10, which is 100, 121 plus 100 is 221, and actually it works. Okay? There it is. Now this one looks difficult, but it's probably the easiest of all of the problems. You see, one of the reasons that quadratics are so practical is that any object moving through the air, if it was in space, would probably go in a straight line. But since we're subject to gravity, it's going to move in a curve called a parabola, which is what, if you graphed a quadratic, you would get. So any formula to predict moving the position of a moving body in the air is going to involve quadratics. Now this one, they actually give you the answer. I would give you the equation. Let's read it. A baseball is hit against the wall of a massive stadium. It strikes the wall 224 feet above the ground with an initial velocity of 80 feet per second. Now we're not even going to consider wind resistance here. The height in feet of the ball above the ground after t amount of seconds, we're not using x here, is going to be already given by the equation. We're giving you the equation. H height equals, and they give you all that. Okay? Now the man hit the ball, and you have to find out how long till the ball comes down and hits the ground. Well, that sounds, in other words, what correct t do you have to put in? What time do you have to put in so that the height of the ball will be, what's the height when it hits the ground? Will be 0. So put in a 0 for height into this equation and solve for t. That's what they're asking you to do. Not that bad if you think about it, because this equation we're going to factor. Remember, when we factor something like this, we take out a common term, and if we can take out a negative, we do so. This one's going to turn out real nice. I'm going to take out a negative 16, and I'm going to get t squared minus 5t, oh please go in, minus 14. This one's not going to be bad. Now let's factor the t squared minus 5t minus 14, and I'll get t and t and minus 7 and plus 2, which means my possible answers for this are either 7 or negative 2. Now I'm looking for t being time, and I don't have a time machine.
That, sir, is illogical.
So I can't have a negative answer here. So the answer is 7 seconds is how long it takes that to come down. And that makes sense if you think about it. That's enough to get you started.
That's all, sir.
Go ahead and try the homework.